Welcome to another session, which is the beginning for the a new module, which is statements and syntax. That's module number 3, and just brace yourself for the exciting content ahead. And before start exploring and expounding the statements and syntax module, I would like to remind you the fundamental building blocks of Python. That's programming a Python programming ladder. Another way to understand the role of statements is to revisit the concept of Python programming ladder. So which we have just talked. This session climbs the hierarchy to the next level. Uh, Programs. The program is the ultimate one. Programs are composed of modules, and modules contain statements. Module contains statements, and statement contains expressions. Expressions create and process objects. So at its core, Python syntax is composed of statements and expressions. Expressions process objects and are embedded in statements. So statements code the larger logic of a program's operation. So they use the direct expressions to process objects we have discussed in previous videos. Moreover, statements are where objects spring into existence. So, and some statements create entirely new kinds of objects. Example, functions, classes, and so on. So statements always exist in modules which themselves are managed with statements. So we climbed up 2 levels, from knowing objects to generating those objects using expressions. So now it's time to code statements with proper syntax. So now let us discuss the syntax components of Python statements. Basically, the syntax begins with a colon character. Colon is the one new syntax component for all statements that have nested inside them. These are also known as compound statements. And compound statements follow the same general pattern of a header line terminated in a colon, followed by a nested block of code, usually indented under the indented underneath the header line as shown here. And these are some of the syntax components which are important to be noted. So parentheses are optional here, and end of line is the end of statement, and end of indentation is end of block. Whereas if you compare with Java, it completely works in a different way. There you have to use curly braces to define the indentation, but here it's a completely different thing. However, we have some few special cases. So the first one is statement rule special cases. In this case, you can write all 3 statements on one line. You can see that example clearly. And the second special case is, it's called block rule special case. So here you can write a if statement together with print in a single line. So that these are the, other than these special cases, by and large we'll follow the same rules everywhere. Okay. Now, following are some of the most widely used statement and their roles in Python. So first one is assignment statements. Assignment statements comes in a variety of syntax flavors. We will discuss this in next slides. Then we will have a print. Then we'll have a print. Print is technically neither a reserved word nor a statement. So we will this is actually a built-in function. And then we have yield. Yield is actually an expression instead of a statement too. So yield is also a reserved word unlike print. Then try and accept and try finally statements were merged. The two were for merely separate statements, but we can now say both accept and finally in the same try statement. And one more thing is with as is an optional extension, and it is not available unless you explicitly turn it on by running the statement from future import with statement. So with this, what we will do is we will open our Jupyter notebook, and we will do a bit of hands-on to get the clear exposure on different types or various types of statements that are available in our Python. Okay. So here is our here is our assignment, various types of assignment statements. So let's look into that. Just a minute. Okay, so we'll as usual we'll begin with the assignment statements. And the first one is so we have a tuple assignment type. So but here this is a normal target, but whereas here we have used arbitrary target, and these are our different objects. So when I call A, I get the first positional object, whereas when I call B, I got a list of remaining objects. So because it is an arbitrary variable, so that's the reason whatever is left, whatever objects which are left after that on the right side, the B arbitrary variable is taking all those objects. So then we will see calls and other expressions type of statements. So this is one example. We have open inbuilt function to handle a file. Okay, so here what I will do, I'll create so I'll open I'll make file to txt file. I'll write it in I'll use it in write processing mode, that is W. Then after that I will add Hare Krishna into that file, Hare Krishna string object into that file. Let me execute it and see what's going to happen. So I have executed it, and then let's see. Here you can see the file. Okay, so now we will use the same file2.txt, and then now this time we will open it in read mode, R read mode, and then we'll use a read method, and we'll read the file what it is there inside that. It is Hare Krishna. So this is how we use call and calls and these types of expressions as a statement, as a part of statement. See here, both this open function is a call statement, and here the read method is another call statement. So that's why I'm including that here. So then we have print calls. Basically print call, this also comes under calls statements. So print is an inbuilt function, so we use print to print something. So here printing the text, that is I love Python. So then we have if, elif, and then else statement. Okay, so for if, elif, else statement, this is a conditional statement. What I have did is, the example that I have taken here is, I will input some number, and my algorithm, my program should find out what type of number it is, whether it is even number or odd number or zero, something like that. That's what. For that, what I have used is, I have if condition, if statement, and a print, then elif statement, and then a print, and then else statement, and then a print. So basically, when I execute this, I'll give 7. So this is odd number. Fantastic. Oh, sorry. Okay, there is. I have to restart my kernel. Just a minute. Okay, now I'll give 8. This is even. Now I'll give 0. Let's see what's going to happen. It's 0. So that's how these statements work. We will look into this conditional statements in detail in our next videos. Okay, so now the one thing I just want you to understand more is, it's about else. So basically, Python supports to have an else statement associated with a loop statements. If the else statement is used with a for loop, the else statement is executed when the loop has exhausted iterating the list. Whereas if the else statement is used with a while loop, the else statement is executed when the condition becomes false. This is the difference I want you to notice. Okay. Then we are moving on to the for else. So if you see this, I use a for statement to step into a iterable object, that is a list. Now I have, once this iterable object has been completely exhausted, in that case only else comes into the picture. Okay, see, I will add one more item and we'll see what's going to happen. See, after 32 we see list else sprung into action. Now we'll look into while else. In while else, what happens is, so I have taken one x variable is for the count and y is for the maximum value. So or in another way, number of iterations. Okay. So now here else comes into the picture if and only if this condition becomes false, unless the condition is proven right, else will not spring into action. So here, once the condition is wrong, so once x is no more less than or equals to y, in that case only that loop moves on to the else. So after printing Hare Krishna 108 times, it has moved to the else statement. Next, we will move on to the pass. Pass statement is like it does nothing. That's it. It does nothing. So, for example, here I want to have for loop, but I don't want to do any action. So maybe I want to use this for loop somewhere else. So in that case, what I will do, I will use pass, and I'll just pass it. So no action will take place. It will just pass the for statement. The same thing I have done here. So here in this loop, when if I is n, you just pass it, you don't print it, you just pass that. But as it is, remaining iterations will take place. That's how our pass works. Then what else we have is a break. So when it comes to break, the break statement in Python, the break statement in Python basically terminates the current loop and resumes execution at the next statement. Just like the traditional break found in C, the most common use for break is when some external condition is triggered requiring a hasty exit from a loop. The break statement can be used in both while and for loop. If you see this example clearly, my target is S and my object is Shiva Shambho. Now my condition is when any of letter M or O comes into the picture, just break the loop. Don't go ahead and comes out and do something else. So here same thing is happening here. I will put B here and we'll see what's going to happen. We'll see, it went there and fetched S and it printed then HIVA. But when it came to B, when it has come to B, when it has come to B, it directly broke the loop here and it moved to the next statement. What is the next statement? That's the print. So that's how our break helps us to move on to the next statement using a condition. Similarly, we will look into our continue. The continue statement in Python returns the control to the beginning of the while loop. The continue statement rejects all the remaining statements in the current iteration of the loop and moves the control back to the top of the loop. If you see this example, I used the for statement, a for loop, to step into a range of 1, 2, 1, 12, a generator function. Now, I have written a condition that if I is 4, I is equals to 4, then continue, else print. So as it is in a for loop, it is a I is our loop variable. Loop variable goes into the range generator range, and then as the first one is 1, it is not equals to 4, then it goes to the else statement and it will print 1, and then second iteration it will fetch 2 and 2 is not equals to 4, then it will print. Then when it comes to 4 is equals to 4, so then what it will do, this one will be executed, this loop, then it will come into it will go inside that condition, then it will execute continue. When it says continue, it should not go down at any cost, it should go back to the header. That's the our for statement. So then it will go up. Then once it goes up, what it will do, it will do the next iteration. So in next iteration we'll print. So that's the reason 4 has not been printed here, and then remaining all other numbers inside that range has been printed. That's how the continue statement will be useful. Then we have a def statement. Basically def statement is used to write a function, to define a function. So here I have used a def keyword, and then function name is f, and then I have used a, b, c is a keyword parameter, and then an arbitrary parameter. So this is my function, and what I want to show to our user is a plus b plus. As this is a arbitrary uh, parameter, I will take the first item in that list. So let me execute this. So my function got executed. Now I want to call this function. So f of function name and then arguments 2 5 3 comma 5 comma 6, these arguments. And now I want to check the type of this result, because I'll get some result and I'll check the type of that result. I got the 12 and the type is none type. It is not int, it is not float, it is not complex, it is none type. So that is the result we got. So but when you want to do some, so for example this function f function, I want to, the result of this function I want it to I want to use with some other function as a input. In that case this none type will not be useful. So then the hero comes into the picture. That guy is a return. So what return does is, return will return will give you an object, a specific object type. See here, I defined, I used the same function, but in spite of printing the result I used return to give a result to our user. Now we'll see what's gonna happen. See, int. So as it is an int object, this result can be used in doing arithmetic calculations or mathematical operations, and later with different other functions. So now we will see yield. Now as we all know that while defining a function to show result to our user, we can use print or we can use return. Similarly we can use yield, but the difference is a return will return will give you only a specific value. See, let me check here. So what you got is value 12. Okay, whereas an yield will give you a generator function. See here, I check the type of that, a generator function. Sorry, just match. I have to execute, I have to define the function first. So we got the generator function. Let me just call it. What you got is a generator object, a gen at this hexadecimal number system at this memory location. So that's the main difference between return and yield. So next we will move on to global. So this is global or local is scopes. These are scopes. Means scope is nothing but where you have written your variable name. So based on that it can be used. The location you defined, the location you have placed will decide the utilization of that variable, of that name. So here x is equals to world, x is equals to world object. In this case it is a global scope because without indentation I'm writing in my module. So whereas after that I have defined a function, the name of the function is function, and then the variable name I have used is x, but the object is a different, that's a new. Now when I call function, I will get new, the value new, because that's called a local scope. And if I just call variable x, I'll get value old because this is global scope. This is how the difference it shows. So we will be talking about this in detail in our module 5. You don't need to worry about it. It's a simple concept, but it's worth understanding. Now, non-local. So non-local is similar to that only. It is also a scope. So here I have defined outer function. Okay. In outer function, my x value is volt. Inside that I have defined another function. The function name is function itself. Inside that function, the x value is non-local. Now when I call the outer function, the value we get is volt, not non-local, because x is equals to non-local to this outer function. That is the reason we get a different value. Now we will move on to the imports. So import is a statement which is used, or it is, in a simple terms, in a layman's terms, it is a gateway to the namespace. So here what I will do is I will import math. So that means I will get an access to the namespace math. In math module, we will have different attributes and different methods. I can actually call them using math.py, and then I can fetch those attribute values, or I can use the methods from that. So in spite of importing complete namespace, I can also import whichever attribute is required for me. See, in this case what I'll do is I will say from math module import only pi attribute and print that. So I got the same result. So but this is we import only whatever is required for us in spite of importing the whole namespace. Then we will be moving on to classes. So classes, as we all know that we have int, float, complex, list, tuple, dictionary, sets, files, plenty of Python objects. These are all core objects. So these are all written by Python inventors. Now, if you want to write your custom objects, then we will use classes. So class is a blueprint to make a new types of custom objects. This is one example. I have used subclass, and then in that I have used this is a class variable. Static data is equals to empty list is a class variable, and I have also defined a method inside it. Okay, so this is one class. Then what else we have is a try except else and finally. So here what happens, the try block will test the accepted error to occur, and accept, here you can handle the error, and using else, if there is no exception, then this block will be executed, and finally block always gets executed either exception is generated or not. So now if you see this example, we have for keyword, and then we have loop variables I comma j and membership operator, and then a zip, and then a zip function. Now what happens, my intention is to do division from both the tuples consequently. Okay, so it should in first iteration it should fetch the first value from the tuple 1, and then divide and then it should be divided by the first value of the second tuple. So now what I'm doing now, I use try and accept method. If in case of any error comes, in spite of completely smashing my completely smashing my program, it will tell you, so this is the problem, and then it will go ahead with the next iterations. So that's what it happened here also. See, if you see in first iteration, 1 divided by 2, you got 0.5. In second iteration, 2 divided by 4, 0.5. Brilliant. And then in third iteration, 3 divided by 4, 0.75. Magnificent. In fourth iteration, 5 divided by 8, 0.625. And finally, the devil has come, 0 divided by 0. So now you got an error. Normally what should happen, if you get an error, this Python will throw you an error, and it will completely crash the code. So then what's the point? Like, your program has been crashed. So to prevent this to happen, what we will do is we'll use try and accept. So try this operation. If error comes, in spite of completely crashing the code, you do take it as a exception and print this. So this some problem has occurred in your code, and then carry on with next iteration. That's what happened. It has told me, it notified us that there is some issue with your code, and then it has moved with a next iteration. So that's how it's helpful. Then we have rise. So basically the rise keyword is used to raise an exception. You can define what kind of error to raise and the text to print the user. So here x is equals to -1 I have taken, and if this condition is right, then I'm saying rise exception, and you also print something so that the user can understand, okay, this is what this is what the type of exception that has been raised. So we'll see rise exception, sorry, no numbers below 0. So this is what the exception is. So next we have with as. With as is basically used to reduce the like to write the same type of code in compound statement. So here what we are doing is, with use open inbuilt function and create a file.txt and write that in uh, open that in write processing mode as a file name, and finally use write method to add a Shiva Mahadeva string into that file object. So this is a compound statement which can be used to write something. And finally what we have is a del statement. So here in del we can use a del keyword to delete any item from a list or tuple. Let's see. So here I think it's 45 has been deleted. Okay, so that's how it works. So now basically we have seen the various types of statements that we can use with Python, and with this we can actually move on to the we will move on to the various types of assignments that we can do with the Python. So now with the Python, we have been using Python assignment statements for a while to assign objects to names. In its basic form, you write the target of an assignment on the left of an equal sign, and the object to be assigned on the right. So the target on the left may be n, name or object component, and the object on the right can be an arbitrary expression that computes an object. Now, for the most part, assignments are straightforward, but here are a few properties to keep in mind. The first thing is assignments create object references. See, that is the main difference between a Java and or Python. Okay, so here what happens is on left side you have a target. This will be stored in a different memory location. On the right side you have an object. This will be stored in a different memory locations. These two will be connected. So that's why you can use your target as a reference, as an identifier, but it will never be, the object will never be stored inside your target location, target memory location. So that's the very important point to be noted. Then names are created when first assigned, and names must be assigned before being referenced. Most importantly, some operations perform assignments some implicitly. For example, function arguments, class arguments, and loop variables are implicit assignments because assignment works the same everywhere it pops up. All these contexts simply bind names to the object reference at runtime. So now the following the following are the different statement assignment statement forms. If you see, this is the most basic form. Spam is that's our target, and another string object, that's a spam, is our object, is our right side, is our object. Now the second thing is tuple assignment, which is positional. You have spam, your target, and ham as a second target. So spam target takes the m object, and ham target takes the capital M object. Similarly, list assignment is also a positional. It also the targets of target list takes the consequent objects of object list. And we have in list or assignment form. So tuple, sorry, tuple and list unpacking. Here Python pairs objects on the right side with targets on the left by position and assigns them from left to right. This is very important. Now the next thing is sequence assignment form. In this, any sequence of names can be assigned to any sequence of values, and Python assigns the items one at a time by position. So next we will move on to multiple target assignment form. In this form, Python assigns a reference to the same object to all the targets on the left. If you see here, A, B, C, these are three different targets, but the object is one, that's span. Fine. Next we will move on to augmented assignments. Augmented assignments is shorthand that combines an expression and an assignment in a concise way. Saying, for example, saying if you take x plus or x plus equal to 2, for example, has the same effect as x is equal to x plus 2, but the augmented form requires less typing and generally quicker to run. Now we will look into most important one. So variable name rules. So variable names must start with an underscore or letter first, second, which can be followed by any number of letters, digits, or underscores. So in simple way, so your variable name should consist of only letter, digit, or underscore. That's it. Not more than that. So now the one thing should be noted down is you should never incorporate characters inside your variable name. Okay, so now we will do a bit of hands-on in our Jupyter notebook, and then we will move on to the another session. So here, let's begin with our assignment statements. That's the basic form. Is again, you have our target here on left side, and then you have object on right side. This name will be used as identifier. When I execute, when I say name, I'll get that object. So this is Shiva Keshava is our object. Next what we have is a similar kind. We have two targets and each has its own object, and when I call that, I will get that object. And then tuple statement. So here tuple statements, you have two targets and two objects. They'll take their respective objects. So p1 comma p2 each took Python comma Java. And then we have list assignment. This is also a positional assignment, but there it is a tuple, here it is a list. The output what we get when you call p1 and p2, that's tuple itself. And then we have generalized sequence assignment. Here on left side we have a number of targets, and then on right side we have a iterable object. So now each target will takes uh, one item from that object. That's how A took K and B took K and C took R. Then we have extended sequence unpacking. So here again, in spite of directly using some list or something like that, we have taken generator object, that is a range of 2, and using list using list typecasting, we have converted that as a list, and then we use a simple a comma b, that's a tuple uh, assignment as a operator, as a statement. So next we have a as a simple as a target, and then asterisk p as argument arbitrary target. So obviously, as it is an arbitrary target, it takes it gives a list. Okay, see here, you see list of 1, and then we have multiple target assignments example. So here we have 3 targets, A, B, C on left side. On right side you have a single object, so each will take the same object. A Devadevam, B Devadevam, and again C Devadevam. That's how it works. And we have the augmented assignments. In augmented assignments we have discussed earlier. So this is the first way, normal way of doing the addition. You declare x is equals to 1, and then you say x is equals to this x and add 1 to that x, and what you get is 2. So in spite of writing 2 lines of code for the single operation, what you can do is you can use a compound expression or augmented statement. So you do that, you'll get the same result. You can also use the same this augmented statement to concatenate lists also. So here I am writing one list, and let's see whether will it be added or not. See, 66 and 8. That's how it works. Again, it got added. And then the final one is our variable name rules. So this is the one way to write. You can start your You can start your variable name with the underscore, and the best way to do and the most heavily used naming convention is just write a simple lowercase name without any numbers or underscores, and the second way is including the underscore and then number. And the way means this is the way we should not do at any cost. You should never start your variable name with one or any numbers. It will throw an error, and you should not include or incorporate any characters inside your name, so this also will throw a fatal error. So with this, we have come to an end of our assignment statements. That's part one of module 3, and I will look for you, forward to see you on next sessions. And by the time, you just keep watching and keep spreading the word to everybody, and keep liking and keep subscribing. And I will see you on next session. By the time, bye bye, tata.